it's good that I was supposed to be the last before the lunch, so I just changed the plan. So it's good to have the presentation now, but also it's difficult after lunch as well. So that is the thing to start with. So today I would thank the PSU community and Adhikari brothers that's giving us an opportunity for Juniper to present what we have in our portfolio and how we really like to address the networks, what are coming in the future, and how we are going to see a lot of innovations which are happening in this field, right? Because today from morning, we heard a lot of speakers talking about like applications, right? The user connectivity, and also actually talking about a lot of the things which they like to do it in terms of automation perspective, right? If you see that they have reduced from months and days to minutes, and even looking at a lot of things which are happening from the ERP perspective, or a lot of things which are happening in the manufacturing whole, there were a lot of good examples and case studies which we saw in terms of how it is getting innovated from the customer perspective or from the PSU's perspective. So I just wanted to talk about few things which we actually forget, right? And it is hidden, which we are not aware of. Because when we talk about applications and when we talk about the users getting connected to the applications, the main concept here is the information flow which happens between these two elements, right? So what we consider is, whenever we see people talking about, they talk about the applications, they talk about the apps, they talk about the users, how they are using the apps and how are they getting benefited. That is the thing which always we hear about. But what we forget about and what is hidden is the underlay, what we call it as a network, right? So we never believe, we take it for granted that there is a network which is a glue which is connecting the users and the applications. But that is the key enabler for any of the technologies which you want to adapt and which you want to use it to make it more operational efficiency. So that is where I am coming from, because it's a ground reality. One is saying that yes, we need to have this kind of apps, we need to have this kind of applications, we need to make it operational efficiency, digitization is actually disrupting it, so we need to adapt the digitization. So these things, even about the Internet of Things, these are the things which we hear again and again. But what we really don't look at it is the underlay of the network, which is actually a glue connecting all this together and giving that information at the right time to take the right decisions. For example, if the mining video, if you have seen, if the network goes down, then at least for 5 minutes, that means 50 trucks will pass through without giving any information for the now to get what is the truck carrying about, right? So these are the things which will affect us. And in the last presentation also we saw that the network will never go down, because he said that only once in a year there was an effect of the network just for 2 minutes or 5 minutes. So that is how we feel that network is there and it is taken for granted. But I just wanted to talk about what are those innovations which are having also from the networking arena, and also which is happening from the data center perspective, because all the applications which are hosted, which you're going to access, are hosted in the data centers, right? And there is a network which glues the data center and the users. So this is where I just want to talk about what are those innovations and at a very high level, and what is that it is driving, so that the networks can be looked at for future, where you can adapt to any kind of technologies you want. That is the key. Just building a network, just for providing a connectivity and going further is not the right way. But what you need to also look at is what can key enabler for my future technologies and future users or future applications which I am going to put on this network, and will it be able to drive and sustain those kind of capabilities. So these are the things which you need to look at when I am talking about network. Network is just not a word, but it is combining everything together to make you successful in terms of the ICT as a platform, right? So I have just put this earlier networks, as we saw, like earlier speakers also spoke about, when we had networks earlier, there were some legacy applications, few applications, and there were some satellite communications, and we were trying to use it, and it was working as far as our applications are concerned. But when we wanted to move towards ERP, when we wanted to move towards a lot of other future technologies, then we had to look at different options, right? So if you look at this, earlier networks used to give connectivity, but there were silos right? DWDM was a silo, network was a silo, telepresence was a silo, right? There were silos of networks and you had silos of management platforms to manage it. So, and it was all manually configured and also the networks were static. That means to say that you used to configure once and leave it, and you used to put those applications and the users onto the network, and you feel that yes, everyone is getting that kind of application experience. But never you thought of that dynamism is required. Because today's world, when you look at those kind of connectivity, what we talk about between machine to machine or machine to the application or to the software, so there is a lot of communication which happens within the network. So these requires lot of qualities which you can look at, which are more coming from dynamism and those kind of activities, right? So moving further, so this is what I talked about. I am saying about the recent networks. Recent networks, if you look at any kind of networks today, you talk about smart cities, you talk about IoTs, you talk about the traffic management system, you talk about manufacturing units being networked together, right? If you look at any kind of networks today, that the networks are primarily application driven. So there is a difference when I talk about application driven and the network driven. Have you seen that we define, for example, a quality of service on a network? Do we know that this particular application requires this quality of service? We just decide ourselves saying that okay, voice I need to give high priority, video I need to give high priority. But that video, does it require the high priority all the time in the network, or it requires high priority only during a period when the video has to run between the offices? So these are the things which we need to look at when we talk about the network. So it is not just building a network, putting a static policies onto the network and say that my network is up, now I can put any applications and start connecting it and I can get the customer satisfaction and the user experience. So that is what I am stressing about, is today the networks are primarily the application driven networks. And today the amount of automation which has to happen on those networks, because we are talking automation on the application level, we are talking automation on the connectivity of communities, we are talking about connectivity of machines together to get the operational efficiency, to get the analytics out of it, right? Health monitoring capabilities. But have we thought of, is the same required for the network? Is automation is required for the network? Because if I want to if I want to start a video conferencing at 11 in the morning, and if my network is congested, can I have some capability so that the congestion can be released and then I can get that kind of quality of service over the network for 1 hour, right? So this is what we talk about when we talk about networks moving towards automation. It is not manual configurations. It is not a configuration that I put a policy on a network and I say any application can take over that policy and give me the customer satisfaction or a user experience. It is never. So the automation is becoming a key criteria. And the second point which we are seeing from all the networks is the customization capabilities. Today, earlier what we used to do in the networks, we used to purchase the COTS equipments and we used to put it, and whatever the features it used to support, we used to compromise on those features and run the network for us, right? But today, that is not the case. Today, what we are looking at is the customization capabilities which can meet the user requirements. If I have some requirement which is other than the features which are given on the network, I should be able to customize those features onto the network. So this is very critical. So customization capabilities which can be inducted into the network to support your applications and to support your requirements. So this is one of the key factors you need to look at when you are talking about, when you are trying to build any networks in your companies. So that is what I was talking about. And finally, I just want to touch upon like security. Security is everywhere. So whether it's a network, whether it's an application, whether it's a data center, whether it's IoT, there is security everywhere. But how do you want to drive that security? Whether it has to degrade your performance when you want to put security on the network, or you want to make it more proactive so that you know what are the effects which are going to cause because of security, or those policies required first of all, which is not being used for last 6 months. Or people are, the administrators are adding more and more policies onto your network which are overlapping, right? So these are the things also which we need to take care when we are talking about these networks which are being built. So moving further, so this is one of the things, right? When we are talking about CDNs, we are talking about SaaS, we are talking about IaaS. So now the connecting of the data centers also has become very critical. So we are talking about fat pipes, thick pipes, Ethernet pipes, right? And also we are talking about how we can do the vMotion across the data centers. We are talking about how we can have the same L2 portability between two DC and DR. So these are the things also which matters when you are trying to build data centers and to connect them together over the networks. So this is what I call it as innovations in self-defining networks. We have heard of SDN, right? Software-defined networks. But there's another way to look at it, self-defining the networks, right? In terms of automation. So one is the key element is the automation. How I can automate the entire network. If I want a path from Jammu to Bangalore and I need to run a video stream and I want this bandwidth to be available for me for 1 hour, can I do it instantaneously so that I can get these characteristics on the network? But today, if you want to do it, you have to see what are all the traffic running between these two paths. I have to move them to the different paths. Then I have to enable this, and then I have to check it out and hand it over so that the video stream can run. But can I instantaneously keep Jammu device and a Bangalore device and say I need this bandwidth, this latency, this jitter, and then I say connect. And then immediately I should get a path where I have all these characteristics and my video stream will work fantastically for just 1 hour. Right? After that, it has to pull it out and put back the services which was already running earlier. So these are the characteristics which you need to look at when I'm talking about dynamic characteristics of the network. So this is one of the things what we talk about the automation perspective. The second what we talk about is the scale. Because we can add applications, we can add users, but does the network has a capability to scale, or it is taking a toll so that certain applications are not working properly or users are not getting the best user experience. So you need to look at the scaling factor when you are building those networks. And the third is the programmability. So can I program the network as and when required? For example, why I need security in all the remote locations, for example. So do I have the capability to push the security only to those locations which I want? So these are the things the programmability brings in when I talk about the networks, right? So what I wanted to say is today when we talk about the NMS or the element management system or whatever when you build a network, in the NOC what you see is a topology. That topology is based on SNMP characteristics, but the topology is based on real-time characteristics. Can you see the network? What are all the traffic going on? What are all the links which are being congested right now? Which path is empty? Which path is congested? What are the traffic going on? What are the real-time traffic? What are the non-real-time traffic? Does the real-time traffic is going in the shortest path? So these characteristics has to be seen when you talk about the networks today because of the applications and because of the information flow which needs to come at the right time at the right place. So when you look at this, there are certain innovations which have happened on the networks which are known as WAN SDNs. So we talk about software-defined networking in data center, but today the software-defined networking has come into the wide area networks. What it does is, it actually builds a topology on a real-time basis. And it does everything in terms of analyzing the traffic, analyzing the congestion, analyzing the paths which the real-time traffic has taken over, and then it will give you a fair idea that this is what your network is right now behaving as per your users and applications. So now you know that what I need to do to some of the applications. For example, there is a disaster. I want to divert all the traffic to one segment so that I can get those parameters immediately to my node. So can you do it dynamically? Once you have this picture, then you can know that this traffic is not congested here. I can divert this traffic through this path and I can get all the characteristics and the parameters. So this is what we talk about the WAN SDNs, and this WAN SDNs has three components. One is known as analyze. That means it will analyze the entire network traffic. It gives the network analysis of the complete network which is across pan India or across your locations. And the second is looking at those characteristics, it will automatically optimize your network. You think of optimizing your network when it is a static network. It takes months to optimize the network. No one has got so much of confidence while optimizing the network because they don't know this traffic is really required or not required. Do I need to divert it, not to divert it, right? There will be a lot of confusion when we try to do the optimization of the network. But when it is automated, When it is automated, then you can naturally do the optimization by itself since it knows the entire topology on the real-time basis. So this is what it does in terms of the optimization characters. The third is the virtualization. So you can do the virtualization of the network so that you can say that this virtualized network can be for the video services, this virtualized network can be for the data services, this virtualized can be services for example, the telepresence, right? So these kind of things which can bring up is known as a WAN SDN controller. It just sits in one central location and it collects all the information from the network and it will help you to optimize the network in minutes or hours rather than doing it months and years. That is the difference what I am talking about when I am talking about automation as a feature. The second one is the scale. That's what I was talking about. One is the bandwidth, the subscribers, and the services. So you keep adding the services, you keep adding the applications, you keep adding the users, but at the end of the day, the network should have the capability to scale. If the network doesn't have the capability to scale, then you will have issues. So that is where we talk about a lot of scaling features. So sometimes we talk about x86 as a platform which can do certain services today, but some silicon is required to make you scale the network. That is the second part of it. And the third part is also programmability. That's what I was talking about, the programmability where it comes in, which feature I want to push to which location, sitting centrally, is what defines the programmability of the network. The second programmability of the network is a customization. For example, if you have two links, and one of the link is giving a lot of errors, the IP doesn't know, so it goes on the error link itself. Can I customize and do something so that the traffic will come to know that this has got a lot of errors and it can move the traffic to the better link which has got lesser errors, right? Automatically if it can do it. So these are the programmability and the customization capabilities which you need to look at when you start building a network. For example, if you are peering with any of the ISP and you are getting all the BGP routes, for example, if you want to see that, can you do a whitelisting of the BGP routes and say that if this is matching with my whitelisting routes, then only you inject into my network. If not, don't inject into the network, send me to monitor it. Right? These are the customization capabilities which you require. That is not there as a normal network characteristics. That's what I just wanted to say. So these are some of the things which we talk about: network function virtualization, the SDN, whatever you may call it as a name, but the characteristics should be in a way where you can customize it and program it as per your requirements. So the second part what I wanted to talk about is also on the security, the proactive security. Today, there are certain innovations which are happening in the security that you don't have to define policies into the firewalls. For example, right? You can connect them to the feeders which are available over the globe. So these feeders will send you the whitelist and the blacklist kind of scenarios to you. Automatically the firewall can build those policies into your network and it can push those policies to the remote locations. So overall the entire network is secured by dynamically pushing the policies to the network. I am not defining any policies. You may define for certain requirements of yours which is required for the network, but for example GeoIP, right? So these kind of capabilities where I need to look at the complete GeoIP and I need to put those policies to stop it. Instead of that, if I get all the GeoIP whitelisting and blacklisting, automatically the policies are built and it goes to all the remote locations. So these are certain things which are happening. And the second is when there is a client server kind of architecture, when the users are coming to the data center and accessing the applications, can you do the service training of those applications? Because today what happens is, when the application comes and hits the data center, you open the packet every time it moves from one security device to another security device to another security device. Can I open the packet once and go through these security devices multiple times and come out once so that I can have the low latency still holding good, but even though it is going multiple iterations on the security and the policy checking happening. So these are some of the things which we talk about the automation characteristics which you can build slowly into your network so that the low latency, the good performance, keeping the user experience all put together in a very fantastic proposition if these characters are taken care when you are trying to build the network. So that is what I want to say. So this is one of the things I just wanted to highlight. So I just wanted to say that this is what we talk about. We talk about underlay, we talk about overlay, and also we talk about the customization and the automation capabilities which are required. When I'm talking about this implies both for the data center as well as the network which you are going, which you build to connect the remote locations. Right? The snapshot, how it looks, the automation and the orchestration is the key today for the networks, and the traffic engineering, application-aware traffic engineering is what is required today. It is just not traffic engineering what we used to talk the last 5 years back. Today it's application aware. If this application is there, then I need to give those characteristics at this particular point of time. After that, I need to pull out those characteristics and give the characteristics to the next application which is coming up onto the network. So these kind of dynamism which is required is what we talk about orchestration. So my last slide is why Juniper I don't want to cover much because we do all this. So I just put it here. Now the network, NETWRK, can be redefined completely in terms of what we see today the networks are. Today we are talking about the new services which are enablement in quick time. We need to enable the services in quick time with orchestration and connectivity capabilities. So this is what I just wanted to talk about, what we talk about network. It is just not network, but we need to rethink and we need to redefine how we define our networks today as per the model what we are going to look at for the next 5 to 8 years in future. Thank you so much.
All these features are available in NMS or your...
No, that's what I'm saying. NMS gives you only SNMP characteristics. These are more coming from something known as a WAN SDN kind of there is a standard protocols which are known as PCE and PCEP. Path computation element and path computation element protocols. So today all the devices support this. Once you have this, these guys send a lot of information to the centralized one controller. That controller will have all the information that this device to this device has got this much of bandwidth, this much of congestion, this much of traffic flowing, everything. For example, I will tell you, if you want to upgrade your devices in the network, you want a software upgrade from one release to the another release. Now the system has to come down and come up. Whatever people say ISSU, everything, always there is a maintenance window which you will take it to upgrade it, right? So in this, when you want to upgrade it, what you will do? You will see what are all the traffic going through that particular path. You try to manually provision it into the different paths and then upgrade it and then bring all those back and put it. At least it will take a couple of weeks to do this. You have to plan it, then you have to execute it, and then you have to bring it back. But with this kind of controller, what it does is, when you say I want to upgrade this device, automatically it removes all those traffic and identifies where this available paths are there for those traffic. It will push those traffic to those paths and upgrade it and bring those traffic back and put it to that particular path again. It is done automatically, you don't have to do anything on that.
True, but this is done by a Juniper network.
We have a, I didn't want to talk about Juniper products, but it is an innovation done by Juniper.
Is it ready? Because we always find the NMS is the most difficult thing to implement.
Correct. So, because NMS only gives you per device management.
No, this is done by NMS or your software?
No, this is done by the software. This is not a NMS, it is a SDN software.
Yes. You have got it.
Yeah, we have got it. Thank you so much.